Okay, so we're told here that the cost of 3 markers, 3M, and 2 pencils, 2P, is $1.80. We're also told the cost of 4 markers and 6 pencils is $2.90. What is the cost of each item? So here, and include appropriate units. Well, we use a system of equations here because it just seems to be the most natural way to do that. What I'm going to do is, because I want to cancel out the 2 and the 6 with 3 and 4, I think 2 and 6 is easier to cancel out because if I just multiply this first by 3, right, that will get me the same p term here as well. So I get 9m plus 6p equals here $1.80 times 3. So you have the graphing calculator at your disposal. Right? We can do 18 times 3 as well. 5.4. Okay, so $5.40. And then 4m plus 6p equals 290. So now what we've done is we can cancel out. Subtract the second equation from the first. 9 minus 4 is 5m. 6 minus 6 is 0. And 540, right, 5.4, oops, 5.4 minus 2.9 equals 2.5, so 250. Right, so 5 markers is 250, divide both sides by 5, and the markers are 50 cents each, or $0.5. So M equals $0.5. So then that's the marker cost. The pencils we can figure out by plugging in. 3 times markers, 0.5, plus 2 pencils equals $1.80. Right? So that's 1.5 plus 2p equals 1.8. So 1.8 minus 1.5 is 0.3, and 2 pencils then equals 30 cents, and each pencil then equals 15 cents. So this is a linear systems problem. You can also graph these two lines and see when they meet. That would work as well. Here we're finding when the line and the quadratic meet here. So it gives the line in mx plus b format, x minus 1, right? Y equals x minus 1. This means that b equals -1, and the slope is 1, right? So here's -1, and our slope just goes right up, 1 for 1 each time. So this is our line right here, and you would grab your ruler, of course, and just graph it. All right. Okay. Then label it. You want to keep track of these things. Y equals x minus 1. So that looks terrible. Let me fix that. Y equals x minus 1. The quadratic itself, here, let's write it out. Y equals x squared plus 4x minus 5. We want to know, when does this quadratic equal the line? Oops. Fix this. Sorry, plus 4x minus 5. So that means at some point this is going to equal the line, so we set them equal to each other. When does x minus 1, the line, equal x squared plus 4x minus 5? So it's generally a good idea to get everything to one side here. So minus x plus 1. And then this equals 0, right? Equals x squared plus 3x, and then -5 plus 1 is -4. So now when we factor this, we're finding when these two things meet. So -4 and 3. What factors of -4 add to 3? Well, I know that +4 times -1 is -4, and if I add them, I get +3. Sorry, this pen is not working very well right now. Okay, that equals 0. And then this means that x plus 4 could equal 0. So subtract 4 from both sides, x equals -4. And this means that x minus 1 could equal 0. Add 1 to both sides, and x equals 1. These are the points where the line and the quadratic meet, except we don't have points yet, we just have x values. Plug those x values into your line, make your life easy, and find the points. So -4, the x value, minus 1 is -5. So one of our meeting points is -4, -5. I'm going to mark that on here. 1, 2, 3, 4. Down 5, that's one of our points. And you would label it too. Maybe choose a better color here. Okay, -4, -5. The other point is when x equals 1. So 1 minus 1, x minus 1, equals 0. The other point is 1, 0. So that's this point right here, our other meeting point, 1, 0. So we're almost done. Now, all we have to do is find the vertex of the quadratic. And that means what I would do is I would just Find negative b over 2a, that's our axis of symmetry. B is 4, so negative b is negative 4 over 2 times a is 1, that's 2. So b equals negative 2. Sorry, b, not b. Negative b over 2a is negative 2. That means our axis of symmetry is x equals negative 2. Let's always give you that vertical line here. So at negative 2, right here, this line, right, is our axis of symmetry. That's where the vertex of the quadratic is, and that's very useful with quadratic functions. So here it is, x equals negative 2. That's going to fold your parabola in half, so it's going to cross the vertex. So plug in negative 2 for x, and that's where your vertex will be. So here, negative 2 squared, x squared, that's 4, plus 4 times negative 2, so that's negative 8, minus 5. So 4 minus 8 is negative 4, minus 5 is negative 9. So our vertex is that negative 2, negative 9. Negative 2, here's negative 5, 6, 7, 8, 9. Here's the point. Why do we do that? Well, to really get a sense of a quadratic, you just have to kind of get 3 points, and that's what we have now. So here's your quadratic, right? It's kind of connecting to these points here. Curves down the vertex and folds back up here. And, you can extend that. So here's our graph, and we found the answer when they meet, and we use the graph to support the algebra. On a calculator, you could just go to y equals and enter this in really quickly, and that's maybe how you do it. X minus 1, enter, and then the other one's x squared, add the exponent there, and then plus 4x, and then minus 5. I should have cleared it off first, sorry. Do it again. X squared, say plus 4x, and then minus 5, enter, and graph. So here, you see the graph of these two things. Oops. Apologize. You see the graph, and if you press second trace and intersect, you can find when they meet. So it asks you for the first curve, so the line, we'll choose the line as a curve, and then toggle over to the quadratic, second curve, enter, and it hits the intersection 1, 0, and do the same process, but scroll over in this area to get the other intersection point. Alright, thanks.